Hi everyone, my name is Prashant Parajuli and I am a graduate student in geotechnical engineering at SIUE. So today I want to talk about something that affects a lot of people living in hilly urban areas, improving slope stability and risk communication. So that is essentially I'm looking at how uh, we can like stop landslides not just with the concrete but by taking to the people living there. Okay, so here is the core issue. We know that hilly regions are prone to landslides, and when they fail, we lose infrastructures, property, and unfortunately, sometimes lives. So, if you look at this diagram, it simplifies the technical challenge. This green line, that's the stable slope. That's where we want to be. But this red dashed line represents a failure surface. That shaded red area is the soil that is likely to slide if we don't intervene. So my argument today is that we need to combine hard engineering with clear communication so communities actually understand what the red zone means before it's too late. Okay, so to give you a real world example, so take a look at these photos. On the left, you see a healthy green hillside before 2013. So on the right, after like August 2014, you can see the devastation caused by a massive fail. So why does this happen? It's really a battle between gravity and the soil strength. Things like heavy rain or poor drainage tip the scale. So I like to use the analogy of the sandcastle. So if you pour water on a pile of sand, it holds for a second, but eventually it turns into a soup and collapses. So soil does the exact same thing. So my goal is to explain that mechanics in a way that regular people can understand. So also this picture is from the Jure landslide that happened in 2014 in Nepal. Okay, so how do we fix this? So I'm proposing with the tackle it from two angles, the engineering and communications. So on the engineering side, we have a toolbox of options shown here. Down at the bottom, we can build the retaining walls or drive sheet piling to physically hold the slope back. So inside the hill, we can drill rock bolts or swale nail to pin loose rocks to the stable ground deeper inside. And critically, look at the drainage pipes here. Managing water is the most important part to stop pressure from building up. But the second part of the solution is explaining this diagram to the public using workshops and simple visuals so they know what we are building and why. Okay, to put this plan together, so I didn't just want to guess. I spent time reviewing existing research papers, government reports, and real world case studies. So I looked at how municipal agencies currently handle slope assessment and more importantly, how they talk to the public about it. So I basically tried to merge the best technical fixes with the best communication strategies I could find. Okay, so obviously we can just fix everything overnight. I have mapped out a 12-month plan to make this workable. So for phase one, the first 3 months are just about assessment, like mapping the risk zone so we know where the problems are. So phase two, the month 4 to 6, and when the heavy lifting happens, that's the engineering design and the constructions. For the phase three, once the slope is secure, we spend month 7 to 9 focusing on the community, like running the outreach programs. And for phase four, just we finish the year by monitoring the site to make sure our fixes are like actually working. Okay, so this approach works. I looked at a few places that are doing things right. Like first we go to the Hong Kong. It's like famous for this. They have strictly maintained, and but they are also run high public campaigns. They have also run the high public campaigns. And in Seattle, they used like digital maps so homeowners can actually look up if they live in a like slide prone zones. And in Nepal, like they use community monitoring where locals are trained to spot cracks or early warning signs themselves. So the big takeaway here, the place with the best safety records are the ones with the public understanding the risk. So to wrap things up, so slope stability isn't just a math problem for engineers. It needs clear communications. Like if we want to prevent landslide, public awareness is just as critical as a retaining wall. It's really a shared responsibility between us engineers, the policymakers, and the community. So if we get that balance right, we can save a lot of trouble and potentially lives down to the road. So here are the references and the agencies I drew data from for this research, including FEME and USGS. Okay, so thank you. So that brings me to the end. Thank you for listening. So I'd love to answer any questions you have about the engineering techniques or how we can better communicate this risk.